So in this lecture, we will discuss the top-down design. And the top-down design, as you can see, starts from the first step, that is requirement analysis, because since we are starting it from the scratch, from the top, so you need to have a requirement analysis. And what actually you do in requirement analysis, if you talk about designing a database, so it means you need to know what type of organization is this, what type of data they are dealing with, what is the size of the data they are dealing with, what type of data is required by various users at various levels, and how many transactions are being generated over a period of time, and other related issues. So all of these things, let's suppose what type of network is available over there, what type of network is available over there, what type of architecture they are following, and whatever the implementation over there. Let's suppose if they have some sort of an existing infrastructure, so we will see that what are the requirements, and by those requirements we try to analyze that what are the objectives to be set, because the requirement analysis gives us the perception that what are the objectives, what objectives you actually want to achieve. And that is only done if you have good requirement analysis based on the given data, based on the given information. For example, we just talked about user access patterns. So of course that also counts whenever we go for the requirement analysis phase. So the most important thing is that what type of data they are dealing with, and in which forms they want to process the data, what type of queries normally being generated in the organization, how user wants that data, what is is there any accessibility problem or not. So we need to know that how their network works, and all these things are relevant. The size of the organization, number of users, as I talked earlier, number of transactions, average transactions. So all of these things help you for the design process. And from there, you can have the objectives, that these are the objectives which you have to meet. Objective means that what you want to implement in your system. So obviously that has to be incorporated in your design. So from there you have the objectives. Let's suppose they want quick access to the data. They want a system which is more reliable. So these are more efficient. So these are some objectives which can be set on the basis of the requirement analysis. And from there you can see there are two branches. On the left, on my left, it is the conceptual design, and on my right, we are talking about the view design. So both of these things become relevant when we start with the design, because we have to go for the conceptual design as well, and at the same level we start the view design. Why? Because whenever we go for the requirement phase, it is important for us to know the users. Normally, whenever we do such a job in any organization, we can divide the organization into three levels. That is also called organizational pyramid. And in that three levels, normally we divide the users or the management, and in the strategic level management, and then or a top level management, and then we can say the tactical level management, or the middle tier management, and or at the lower level management we can say the operational management. So what we do is we can divide the organization into various kinds of users, because every users must have a different requirement, not the same requirement. So group of users may have different requirements. The top level management may require data in another manner. The middle tier requires data in the way they need that data, because they have to make the analysis, they have to make the decisions. And obviously at the operational level, how that data will be actually executed, how the operations will be executed, and how it can be done, it can be implemented. So for the view design, it is very important to know what type of input is required at the user level. So at the same time, we need to know that how we define how we design the user interfaces, what will be provided in the user view, and at the same time, we go for the conceptual design. And when I say the conceptual design, it is always augmented by the view design, because from the view design we have that information that how users need that particular data, and that can be incorporated in the conceptual design as well. So whenever we talk about conceptual design, we always if we are talking about relational data model, so for the conceptual design we can use ER model as well, because that entity relationship model also you can say is sort of a conceptual design. So conceptual design leads to the global conceptual schema. So the definition of conceptual design leads to the global definition of the conceptual schema. Let's suppose if you want to implement a company database, so you come out with a global conceptual schema, and that global conceptual schema has the complete definition of the whole system. In the view design, you have actually you go for two things. Number one, ES stands for external schema. Those view design help us to design the external schemas. And second thing which is helpful from the view design is called the access information. And this is very important, because on the base of this access information, it is really helpful in distribution design. That is why you can see the arrow is coming from the access information. That access information actually tells us that how the data is being accessed by the users, or to be accessed by the users. How many queries have been generated over a period of time? Which users require what type of data is required from these particular users, what type of data is required by these particular users. All of that information actually comes from the access information, because the access data help you to identify the amount of data which has to be received by particular users. And when I talk about access information, that is actually all statistical in nature, because you have all those statistics with yourself. For example, total number of queries generated, average number of queries generated, average number of queries where the relation 1 and 2 is used, average number of queries where a particular attribute is being used, queries where all the tables are involved, queries where only single tables are involved, blah blah blah. All of these are what these are all counted toward the access information. This data you will see in the next slide or so, that is very helpful when we make the distributed design. So one is the global conceptual schema, the global definition of the database which you want to implement. Number two is the access information. And obviously number three is the external schema, because that gives you the clear picture of the data definition in terms of the users. So we have the GCS definition, we have the access information, and then we have the external schema. So all these things, and use user input, which is very important, because all the time you have the user input. So whenever you are designing such systems, you have a continuous input from the users as well. So all of these information help us to make the distribution design. And once you have come up with the distribution design, then it means you have created the LCS. तो डिस्ट्रीब्यूशन डिजाइन बिल्ड कर लिया, इसका मतलब है आपने LCS बिल्ड कर लिया. And LCS stand for local conceptual schema. And actually when you develop the LCS, it means you fragmented the data. Actually you make the fragments, you have distributed the data. So that is why you come up with your LCS. Maybe you have 3 LCS, maybe you have 4 LCS, whatever, because it is based on your own problem and based on the existing data you have. So it might differ from organization to organization. It might differ from implementation to implementation. So once you have your local conceptual schema, then you need to have a physical design. And once you have the physical design, it means how data will be stored. So if you know how data will be stored, then it means you are talking about local internal schema. And of course, when you talk about local internal schema, it means that the data component which is residing on a particular site or a data server, so that data server is residing on a particular site. It means the internal schema is there on that particular site, on that particular drive of the server. So that is the whole picture of the top-down design. So whenever you are building applications from scratch, you think in that way, and then you develop all the fragments. And obviously, here the black part, which is the distribution design, there are other lots of things comes under this, which we will discuss in the coming lectures. That how you will use that information to convert this into LCS, because there are more than one ways of distributing this into LCS and to the physical design or to the LIS. So that is the concept regarding. Okay. Now we will discuss the issues which are related to distribution design. These are the 6 issues which are very important whenever you are designing such an application. जब भी design करने जाएंगे, you must have answers of all these 6 things with yourself. If you don't have the answers of few of these questions, then you might not be able to design it correctly. So these are called distribution design issues. Number 1, the first question says that why fragment at all? The question means that is there a need of fragment? Why fragment at all? Maybe there is no need of fragment. So first question is that you have to come up with an evidence that the fragment is important. Here the fragment is required. Here the partition is required. So therefore, first decide that why you are going to fragment. Is it the best solution in the given circumstances? Let's suppose you have the reply in positive. You have an affirmative reply. Then number 2 question. Let's suppose the first question, the answer is yes. Then there is a second important question. Let's suppose if fragmentation is required. Then the question is how to fragment, how you will make the partition, what type of database you are dealing with, and how you break the data, and how obviously you have some options with yourself. For example, if you talk about the relational database environment, so in the relational database environment, either you go for the vertical fragmentation or you go for the horizontal fragmentation, because in the relational model, the main entity we have is the relation itself. So breaking the relational database means breaking the relation, and you can break the relation in 2 ways, either vertical slicing, by vertical slicing, or by horizontal slicing. If you are breaking the relation using vertical slicing, it means you are dividing the relation into 2 or more in terms of attributes. And if you are breaking the relation in terms of horizontally or horizontal slicing, then it means you are breaking the relation in terms of records, in terms of rows. So maybe some records will go into one fragment, another record will go to another fragment. That is what you do in reply of the second issue. And what about the third one? Third one says that how much to fragment. Okay, it is decided that fragmentation is necessary. And number 2, you know that how to fragment, but how much to fragment? How much you want to break a relation? A relation, let's suppose if a relation has, let's suppose 7 attributes, and that relation has 100 rows. And let's suppose if I want to say you what is the least possible fragments which are possible. So my reply will be that you divide the relation into 2, because it is the least possible fragment which is possible within that relation. So you can either divide it into 2, 3, 4, and so on and so forth. So let's suppose if you want to divide a relation in terms of rows, in terms of records. तो अगर 100 रिकॉर्ड्स हैं, मैं आपसे कहता हूँ 100 में ब्रेक कर देंगे, वर्स्ट सिनेरियो है. ऐसा करना भी नहीं है हमें. मैं तो सिर्फ बता रहा हूँ कि वर्स्ट सिनेरियो क्या हो सकता है, और बेस्ट सिनेरियो मैंने आपको बता दिया वो क्या हो सकता है. but it all depends upon the problem we have, how much fragments are required. Maybe 3 fragments required, maybe 2 fragments are enough, maybe 4 fragments are enough, I don't know, according to the given problem. That is the reply for the issue number 3. And what about issue number 4? Let's suppose you have decided about the fragment, you have made the fragment, fine, you have made the fragments, but how you will ensure that whatever the fragments you have created are correct? So it means there is some criteria to check or to validate or to correct to check the correctness of the fragments. And let's suppose if those checks fail, let's suppose if that correctness का जो check है वो fail हो जाए, तो इसका मतलब है कि जो those fragments are not created according to the given constraint. So you have to recreate the fragments, because if the correctness condition fails, then you will not proceed. So that is the issue number 4. We have to test the correctness of those fragments which we have created in the problem. Number 5, let's suppose it is all okay. How to allocate? Where you want to have that, let's suppose you have partitioned the database into 3, but how you make this decision that the partition 1 will reside on this node, the partition 2 will reside on another node, and similarly the partition 3 will be residing on another node. How you will allocate it? What strategy you will be using for the allocation? And what type of information is required for each fragment? Whenever you partition those fragments, so you need a certain information. Information required चाहिए होगी ना, data के हवाले से चाहिए होगी, कितना data है, किस तरह का data है. So all that information is required whenever you are dealing with such problems. So these are called distribution design issues. Fragmentation. When we talk about fragmentation, the first very question comes into our mind, that what is a reasonable unit of distribution? What to distribute? So if we are talking about a relational database environment, relation is the reasonable unit of distribution. And what we do is we break the relations, and normally we call it views. When we break the relation, we call it views. So views are what? Are the subset of the relations. So let's suppose if there is a relation employee, I come out with the fragment of the employee. I made 3 fragments: employee 1, employee 2, and employee 3. 3 tables have been created out of 1. So what I did is I made 3 fragments. So all these fragments of employee are also considered as views. And obviously when they are views, so they must be present on a particular network, on a particular site. So obviously locality does matter. That is why we call it locality. It means that has to be localized at a particular site. So जितने ज़्यादा views होंगे, जितनी ज़्यादा distribution होगी, it needs extra communication. It needs extra communication. If it is at one place, so communication is routed to only one place. So if we have distributed into 2, 3, or 4 places, obviously we need some extra communication which is required. Fragments of relations, that is also called sub-relations, or also called as views, as I mentioned in the previous statement. So concurrent execution of number of transactions that access different portions of a relation. And obviously we have a concurrent execution, we have a parallel execution, because number of users are accessing that data. And obviously there are multiple queries which is acting upon, or number of applications which are acting upon the same data or a portion of the relation. So there is a concurrent execution which happened in the same manner. So let's suppose a query is being distributed, and part of the query is sent for the employee 1, part of the query is sent for the employee 2. So that is being done in parallel, not sequentially. Sequentially नहीं होगा कि पहले employee 1 से होगा, फिर 2 से होगा, फिर 3 से होगा, बल्कि actually it is parallel. Views cannot be defined on a single fragment, will require extra processing. So any query or any application जो मेरे एक कंप्लीट इंफॉर्मेशन को नहीं दे रही और उसमें एक से ज्यादा व्यूज इन्वॉल्व हैं, तो इसका मतलब क्या है, जब एक से ज्यादा व्यूज इन्वॉल्व है तो एक्स्ट्रा प्रोसेसिंग इन्वॉल्व है। लेट सपोज मैं क्वेरी करता हूँ और उस क्वेरी का रिस्पॉन्स मुझे एम्प्लॉय 1 से ही मिल जाता है, तो एक्स्ट्रा कम्युनिकेशन इन्वॉल्व नहीं है। लेकिन लेट सपोज इफ आई मेक अ क्वेरी which involve the employee 1 and employee 2, so now extra communication is involved of employee 1 and employee 2. The last bullet is regarding semantic data control. So if we have distributed our relations, we need to have a semantic data control. When I say semantic data control, it means check, integrity check. That is why we call it integrity enforcement. That is why we call it integrity enforcement. We have to enforce the integrity, because if we will not enforce the integrity, then there will be a violations. And those violations में क्या होगा, कहीं EMP1 में अपडेट हो जाएगा, EMP2 पे नहीं पता होगा, या EMP2 से EMP1 को जो इंटीग्रेट कर रही थी इंफॉर्मेशन वो अगर नहीं है, तो फिर इसका मतलब है इनकंसिस्टेंसी क्रिएट होगी। सो ऑब्वियसली बड़ी आसान सी बात है कि अगर एक जगह पे चीज होती है तो आप कहते हैं ना सर मुझे हैंडल करना आसान है, लेकिन अगर मैं इसको 3 जगह पे रख लूं तो फिर तीनों जगह को मुझे हर वक्त अपडेट करना है, कनेक्ट करना है आपस में, ताकि इंटीग्रिटी मेंटेन करे। तो अगर इंटीग्रिटी लूज हो जाएगी तो फिर कंसिस्टेंसी लूज हो जाएगी, अगर कंसिस्टेंसी लूज हो जाएगी तो फिर रिलायबिलिटी कम हो जाती है। सो फॉर दैट पर्पस वी नीड टू इंट्रोड्यूस चेक्स, कंडीशंस, कंस्ट्रेंट्स, दैट इज कॉल्ड सिमेंटिक डेटा कंट्रोल। ठीक है, और जिसको हमने वी विल डिस्कस दिस इन अ कंप्लीट चैप्टर। ठीक है, एंड यू कैन सी हियर द एग्जांपल ऑफ horizontal fragmentation. Here you can say there is a relation called project, and you can see yourself that there are 5 projects which are mentioned in the project. And what we did is we made the horizontal fragmentation based on a simple query which says the budget of the project less than 200,000 and budgets of the project greater than 200,000. So in that manner, 2 records come into the project 1, 3 records come into the project 2. So what we did is we defined 2 relations, 2 views you can say, or sub relations of project, and these sub relations are also called fragments. The same example here will be defined in terms of vertical fragmentation, and you can see the same relation project, but here the same relation project is divided in terms of, not in terms of the value of the budget, but it is divided in terms of the attributes. You can see yourself the project 1, that is information about the project budget, and project 2 is information about the project names and location. So what we did is we divided the attribute. 2 attributes come in the project 2 and 1 attribute budget goes into the project 1. So whenever we go for the vertical fragmentations, we have to replicate the key. So key is not included as the distribution factor. Actually, key is being used in every relation, which is actually helpful in integrating these 2 relations. So how many fragments you have? Like, let's suppose here we have 2 fragments. So in both the 2 fragments you have the P number. Let's suppose if it is divided into 3 fragments, even then the project number will come in all the 3 relations. Okay, because the project number or a key value will always replicate in all the sub relation or views which are being formed by using vertical fragmentation. The पहली example हमने देखी, that is horizontal fragmentation, and the second example which is called vertical fragmentation. This is called degree of fragmentation. Degree of fragmentation means how much to fragment. How much to fragment, that is the question we have. So if you are talking about attribute level distribution, let's suppose we have 5 attributes. तो मैक्सिमम मैं कितने में ब्रेक कर लूंगा? 5 में ब्रेक कर लूंगा भाई, इससे ज्यादा तो नहीं कर सकता ब्रेक। कम से कम क्या हो सकता है, 1 में 3 हो जाए, 1 में 2 हो जाए, 2 में ब्रेक कर लेंगे। ठीक है, सिमिलरली अगर रिलेशंस में डिपेंडिंग, सो फाइनाइट नंबर ऑफ ऑल्टरनेटिव्स आर पॉसिबल, but we have to find out the suitable level of partitioning within this range. तो मुझे क्या करना है, बहुत ज्यादा फ्रेगमेंटेशन करेंगे तब भी तो आपका डिजाइन कॉम्प्लेक्स हो जाएगा, और जो आप अचीवमेंट चाहते हो अपने रिलायबिलिटी के टर्म्स में, एफिशिएंसी के टर्म्स में, वो आपको नहीं मिलेंगे। तो वी हैव टू गो फॉर द ऑप्टिमल डिस्ट्रीब्यूशन। सो ऑप्टिमल डिस्ट्रीब्यूशन जो भी होगी वो आपके लिए सबसे बेहतर होगी, वो आप उससे आपकी एफिशिएंसी भी इंक्रीज होगी, उससे आपकी रिलायबिलिटी भी इंक्रीज होगी। तो व्हेनेवर वी आर डिजाइनिंग सच थिंग्स, तो फिर हमें क्या करना है, उसी में रहते हुए हमें चेक करना है कि यार ये इसमें फॉल करता है या नहीं करता. लास्ट स्लाइड विच विल डिस्कस फॉर टुडेज सेशन इज रिगार्डिंग द करेक्टनेस ऑफ फ्रेगमेंटेशन. अभी हमने पीछे बात की थी कि whenever you create fragments you have to check it. So these are called tests for the correctness. So there are three tests of the correctness. Number one, you have to check the completeness. What is the completeness? It says that the composition of relation R into fragments R1 to Rn is complete. When it is complete, if and only if, सिर्फ और सिर्फ कब, each data item in R can also be found in some Ri. ये नहीं हो सकता कि आपने एम्प्लॉय में 100 रिलेशन थे, उसको ब्रेक किया आपने 2-3 रिलेशन में, एम्प्लॉय 1 और 2 और एम्प्लॉय 3 में, और एम्प्लॉय में एक रिकॉर्ड था वो तीनों में नहीं है. तो अगर तीनों में नहीं है तो इसका मतलब है कंप्लीटनेस नहीं है. It is not complete. So if it is not complete, by definition of correctness, this fragment cannot be, it means the fragmentation is not correct. So that is the first thing in the correctness, that is called to check the completeness. Second is called reconstruction. Reconstruction means that if relation R is decomposed into fragments R1, R2 and dot 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 Rn, then there should be exist some relational operator. कहता है कि अगर आप ब्रेक कर दें और कोई एक ऐसा ऑपरेटर हो जिससे दोबारा रिकंस्ट्रक्ट करें, तो वही ओरिजिनल रिलेशन मिलना चाहिए जिससे हमने ब्रेक किया था. ये ना हो कि मैंने रिलेशन को ब्रेक तो कर दिया एम्प्लॉय 1, 2 और 3 में, जब मैं उनको रिकंस्ट्रक्ट करता हूं तो ओरिजिनल रिलेशन नहीं मिलता. मुझे ओरिजिनल रिलेशन मिलना चाहिए. दैट इज द कॉन्सेप्ट ऑफ reconstruction. And last concept is called disjointness. If relation R is decomposed into fragments R1 to Rn and data from Di is in Rj, then Di should not be in any other fragment. तो अगर मैंने एम्प्लॉय को एम्प्लॉय 1, 2 और 3 में ब्रेक कर दिया है और एम्प्लॉय 1 में जो है वो अली मौजूद है, तो वही सेम अली फिर एम्प्लॉय 2 में नहीं होगा या फिर एम्प्लॉय 3 में नहीं होगा, वो किसी एक में होगा. वो तीनों फ्रेगमेंट में नहीं हो सकता, और ऐसा भी नहीं हो सकता तीनों में ना हो. ये दोनों कंडीशंस फुलफिल नहीं होगी. दैट इज द कंडीशन ऑफ disjointness. So basically, as far as the correctness is concerned, so there are three things to we have to verify about those fragments. One is called the completeness, second is called the reconstruction, and third one is called the disjointness. So here I'll finish my lecture, and hopefully you will understand the lecture today, and you will follow the chapter in the book, and then you may come up with your questions next time. Thank you.